Section 5.7, rectilinear motion using integration. All right, so before we said that if we're looking at rectilinear motion, a position of rectilinear motion, the position function is given by s of t, right? Velocity function was given by v of t, acceleration function we call a of t, okay? And recall also that if we started out with the position function s of t, the velocity function v of t was equal to what? S prime, right? So we took the derivative of the what? Position function. So now we're going to look at going backwards. We're going to look at, let's suppose we're given a velocity function, okay? V of t. And if I want to get to the position function, s of t, what am I going to have to do? I'm going to have to take an antiderivative, or I'm going to have to integrate the velocity function. Let's say I start out with the acceleration function, okay? And I want to get to the velocity function. Well, we know if we take the derivative of velocity, we get acceleration, right? So if I take antiderivative of acceleration, I should get the velocity function, okay? Now let's suppose we start out with the acceleration function and we want to get to the position function. Then what do? We integrate twice, right? Because if you start out with acceleration and integrate once, you get the velocity. If you integrate that velocity, you get the what? Position function. All right, so what we have here is v of t. To formalize this, your book says this. It says v of t is equal to the integral of a of t. And it says that s of t is equal to the integral of v of t. All right, so that just kind of sums up what we said. We're just looking at the same thing again, but from the other perspective, okay? From the integration perspective. All right, so let's see what else we have here. We have an example, and it talks about a particle moves along an s-axis. For each part, find the position function of the particle. All right, so for part A. For part A, we have v of t is equal to t to the 2/3, and s of 1 is equal to 0. We're going to call that our conditions, okay? So what are they saying right here? They're saying that whenever I input into S, I input a 1, I'll get an output of 0, okay? Now what do they want me to do here? It says a particle moves along an s-axis. So that means you have a particle rectilinear motion. Find the position function of the particle. So what am I given? I'm given a velocity function. So my position function, s of t, should be the antiderivative here, or the integral of my velocity, right? Well, take the integral of the velocity function, which is what? T to the 2/3. All right, how do you integrate this? Add 1 to the exponent, divide by the new exponent. So what's that going to be? T to the what? 5/3 divided by 5/3, or I could say times what? 3/5 plus my arbitrary constant c, because I'm not dealing with limits of integration here, right? All right, well, what do I know right here? I know, okay, here's a function s of t for my position function with a constant c. But they tell us in this case that if I input 1 into my position function, so if I input 1 in the place of t, what do you do there? You say, let's call that t1. And if I input that 1, I should get out what? 0. So this 3/5 times 1 to the 5/3 plus c should output a 0. Well, if I put in those conditions right there, that allows me to solve for c. All right, first of all, what's 1 to the 5/3? 1. 3/5 times 1 is just 3/5, right? So 3/5 plus c is equal to 0. So what does that mean c is? C will be negative 3/5. So now go back to your position function right here, but instead of this c value, let's put in -3/5. So my position function, s of t, will now be 3/5 times t to the 5/3 plus this -3/5, like that. There we go. If they give us conditions like that, we could, find our c value. Let's look at part B. All right, part B says this. They have a of t is equal to the square root of t, and then they say v of 4 is equal to -2, and they say that s of 4 is equal to 25, okay? And they say particles in rectilinear motion, find the position function of particles, basically what they say. All right, so they want me to find a position function of a particle. So what I'm shooting for is some s of t here, right? All right, what do they give me? They give me the acceleration function and some conditions, right? So if they give me the acceleration function, I can find my velocity function by integrating that. Let's do so. So I'm going to say my velocity function, v of t, is going to be given by the integral of a of t. All right, so that's the integral of a of t, which is what? Square root of t, right? Now, I guess you could do a rewrite here of t to the 1/2, right? And then take the antiderivative of that if you want. T to the 1/2, if I integrate that, what do I get? 1/2 plus 1, or what? 3/2? Divided by 3/2, or I could say times what? 2/3 plus my arbitrary constant c, because I do not have limits of integration. So what is this? This is my function v of t without knowing my constant c. However, they tell me that whenever I input forward to v, I get out -2, right? So if I input 4 in for t, it'll look like this, right? And then this 2/3 times 4 to the 3/2 plus c should give me an output, or should calculate to -2. Well, I could say, okay, this is 2/3, but instead of saying 4 to the 3/2, I could say that's the square root of 4 quantity cubed, right? Because that's the square root of 4 cubed plus c is equal to -2. Well, that's what? 2/3. What's the square root of 4? 2. What's 2 cubed? 2 times 2 times 2, right? Which is 8. Plus the c is equal to -2. Now if I multiply this, I get what? 16/3 plus c is equal to -2. Now let's solve for c here. So we'll go ahead and subtract 16/3. So c is equal to -2 minus 16/3. Or what could I say? Instead of -2, what could I call that? -6/3 minus 16/3. So what does that give me? -6 minus 16 gives me -22/3, right? All right, so with -22/3 then, what do I do with that value? Let's find our function v of t, which was this stuff right here, right? But instead of c right here, I'm going to sub in this -22/3. So we have v of t is equal to 2/3 times t to the 3/2 plus this c value, or I should say minus 22/3, okay? There's my velocity function. But look at your directions. What do they want you to find? They really want you to find your position function, right? So let's find our position function. How do we do so? Well, to find our position function, S of t, what we're going to do is integrate our velocity function, v of t. All right, so we have the integral of, well, my markers are drying up here. So we have the integral of v of t, which is this stuff, 2/3 t to the 3/2 minus 22/3 dt, right? All right, well, we know how to integrate this. I have 2/3. How about t to the 3/2? Add 1 to that. What does that give you? T to the 5/2? Divided by 5/2, or times what? 2/5. Minus 22/3 t plus your arbitrary constant c. So that gives me what? 4/15 times t to the 5/2 minus 22/3 t plus c, and that's what S of t is, right? But if they give me these conditions right here, then what can I do? I can use that to find c and get a more specific function. So let's do so. So when I input 4 into S, so take S, input 4, S of 4, that'll give me 4/15 times 4 to the 5/2 minus 22/3 times 4 plus c, right? If I input 4, what should I get out as an output? 25. So I can say 4/15 times 4 to the 5/2 minus 22/3 times 4 plus c will output or recalculate to 25. All right, well, let's solve for our c value, our constant value there. Let's see, so that's 4/15, and what is this? The square root of 4 raised to the what? 5th? Minus, well, 4 times 22 gives me 88, and that's over 3, plus c is equal to 25, right? All right, so we have 4/15 here, right? Times, square root of 4 is 2, right? What's 2 to the 5th? 32? Minus 88/3, plus c is equal to 25. And let me see something here. No, I can't simplify that, right? So multiply 32 times 4. And what does that give you? 128/15 minus 88/3 plus c is equal to 25. Right? Okay, so right here, what I'm going to do instead of wasting time for a video, I'm just going to say, okay, if you solve this, you get 229/5, okay? So then, what do I have here? My position function was given by this, but now it could be more particular and substitute in for this c, this value, okay? So S of t, we said before, was 4/15 t to the 5/2, 4/15 times t to the 5/2 minus 22/3 times t plus 229/5, plus 229/5. All right, let's see what's next. What's next is your book talks about what, or your notes talks about this. Let me go to your notes. Your notes talks about displacement and distance traveled. It says displacement over the interval is its final coordinate minus its initial coordinate, okay? And then we have this. Let's suppose we have an interval from t subscript to 0 to t subscript to 1, like some time you start at and you go to some finish time, okay? Maybe it's 5 seconds, maybe it's 8 seconds, whatever, okay? The displacement. Thanks about displacement this morning. The displacement of your particle is going to be your function s evaluated at the endpointed interval minus your function s evaluated at the starting point, okay? So it's basically final position minus initial position. Okay? But what does this look like? To me it looks like this. Just go with me here, okay? What if I take the integral, and my lower limit of integration is t subscript of 0, upper limit is t subscript of 1 of my velocity function? What will that give me? Well, what happens whenever I integrate velocity? What do I get? I get position, right? And where do I need to evaluate it from? T subscript of 0 to t subscript of 1, right? And how do I do this? I evaluate s at t subscript of 1 minus s evaluated t subscript of 0, right? Well, doesn't that look like that? Yeah. So what are we saying? We're saying a displacement we can get by this integral right here, okay? Let's write that down. Let's formalize that. Let's go ahead and write that down over here. All right, see, your book says this: displacement over the time interval, from t subscript of 0 to t subscript of 1 is going to be the integral from t subscript of 0 to t subscript of 1 of v of t. Okay, that'll be how we calculate the displacement here. How about the distance traveled? How about the distance traveled? Distance traveled during time interval from t subscript of 0 to t subscript of 1. That's going to be given by this: the integral from t subscript of 0 to t subscript of 1 of the absolute value of your velocity function, okay? And what's the difference between displacement and distance? Remember, if you have a particle traveling here, and it starts here at 0, and it goes to 2, goes back to 0, its displacement would be 0, because where it ended is 0, where it started was 0, right? The displacement is what? Final coordinate minus initial coordinate. So if it started at 0, ended at 0, 0 minus 0 is 0, right? But it traveled a distance of what? 2 plus 2 more units are 4. All right, let's take a look at what we have next. Our example that we have next looks like this.